Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at problem solving with composite solids. So what is a composite solid? It's pretty much a solid that consists of two or more different solids. So let's have a look at question 1. This composite object includes a hemisphere and cone, as shown. Part A. Find the surface area, rounding to 2 decimal places. So we know surface area is the total area around the outside. So we have a look at this hemisphere. We do not include the base of the hemisphere, which is the circle, because it's not on the outside, it's actually on the inside. And the same part here is also representing the top of the cone. That's also on the inside. It's not technically on the outside, so we don't include that. So, for question A, we know that the surface area is the area of the curved surface of the hemisphere. So that's half of, actually let's just do it as this. It's just 2 pi r squared. And the curved surface of the cone is pi rl. Okay, so make sure you know your formulas. We've got surface area of a sphere is 4 pi r squared, so that's a sphere. And the surface area of a cone is pi r squared plus pi rl. Okay, but because we only have half a sphere, we just halve that to make it 2 pi r squared, and because we only have the curved surface of the cone, we only need the pi rl. So, what is the radius? The radius, we can see here, although it doesn't say what the radius is, we can see that the height of the full solid is 7, and the height of the cone is 5, which means that this bit here has to equal to 2 centimeters. And that there actually represents the radius, because this is a hemisphere, that's the radius, this is the radius, so this is also 2 centimeters. So the radius is 2. Now L is the slant height. We don't have the slant height. This is L. Okay, we need to work that out. And we use it, in order to work it out, we need to use Pythagoras' theorem. So because that's the hypotenuse, is equal to the square root of 5 squared plus 2 squared. And so now we can just put this in our calculator to work it out. To give us 58.97 to 2 decimal places. Centimeters squared. Part B, find the volume. Well, the volume is equal to, the volume of a hemisphere is half of 4 on 3 pi r cubed. Okay, remember this is the formula for a full sphere. But then we need to add the volume of the cone, which is 1/3 pi r squared h. Alright, so let's substitute values. Half of 4 on 3 pi times the radius, which is 2 cubed, plus 1/3 pi times the radius of 2 times the height of the cone, which is only 5. Okay, the perpendicular height of the cone. So let's put that in our calculator. Half of 4 on 3 pi times r cubed plus 1/3 times pi times 2 squared times 5. 37.70 centimeters cubed. Alright, question 2. A monolithic structure has a cylindrical base of radius 4 meters and a height of 2 meters, and a hemispherical top. what is the radius of the hemispherical top? So we know that the radius is this bit, which is going to be the same as the bottom, so it's going to be 4 meters. Find the total volume of the entire monolithic structure correct to 1 decimal place. How about you pause the video and have a go with this one yourself? Okay, so volume is the volume of a cylinder, which is pi r squared h, plus the volume of half a sphere, so half of 4 on 3 pi r cubed. So we have pi times the radius squared times the height. This is the cylinder, so we're doing the height of the cylinder. And then we've got half of 4 on 3 times pi times the radius of 4 again, but this time it's cubed. So let's put that in a calculator. $234.57. Now the question says correct to 1 dp, so that's 234.6 meters cubed. All right. Question 3. Find the exact surface area and volume of the composite solid below. So pause the video, have a go with this one. Alright, so surface area. This is the harder one. So we can see here that we've got a cube. So I'm going to actually work out the area of one of the faces, and then times it by 6. So we've got s squared times 6. Okay, so that's the area of 6 squares. But I don't actually have 6 full squares because of this circle. So I actually need to minus that circle, which is pi r squared. Then I need to add the curved surface of the hemisphere. And we know the curved surface of a hemisphere is just 2 pi r squared. Now, I could choose to simplify this. So let's just do that. That's saying 6s squared minus pi r squared plus 2 lots of pi r squared is pretty much plus 1 lot of pi r squared. Okay, so let's just sub in the values now. 6 times 2 squared plus pi, let's do it in orange, plus pi times the radius, which is 1. The radius is 1. Alright, half of the 2. And then we can put that in our calculator to give us our final answer. $27.14. Now, this here says find the exact surface area. So technically, I really shouldn't be typing pi in my calculator. So let's do this again. That bit there is 24. And we know 1 squared is 1, so technically it's 24 plus pi. 24 plus pi. And surface area, so this will be in meters squared. I'm just going to put that in brackets because all of it is part of this surface area. Alright, what about volume? We know that volume is equal to s cubed, because that's a cube, so the side cubed, plus the volume of a hemisphere, which is half of 4 on 3 pi r cubed. Alright, so let's sub in values. The side is 2, so we've got 2 cubed. And the radius is 1. So if we put that in our calculator, now, because we want exact, let's just do this bit. We know that's 8. And then in my calculator, I'm going to type this in without the pi. So we've got half times 4 on 3 times 1 cubed, which is 2/3. So we're going to put the pi at the top. 2 pi on 3. This is volume, so the units is meters cubed. But again, I'm going to put this in brackets. Okay, because that represents the entire volume. Alright, let's move on. Question 4. Find the exact surface area and volume of the composite solid below. Alright, maybe pause the video, have a go with this one. Okay, so for this one here, surface area, we've got a closed hemisphere, which is 3 pi r squared, but we need to minus the square here. So we need to subtract this square. So we've got 3 pi r squared, but we need to minus the square, which is s squared. And then we need to add 4 triangles. Now, the question is, are all the triangles the same? Well, because the base is a square, we can say that all of the triangles are exactly the same size. So we can therefore add, because this is the surface area, we need to add 4 lots of half times base times height. And remember, it's the perpendicular height of the triangle, not of the pyramid. So let's sub in some values now. 3 pi times the radius. The radius here is √2. Then I'm going to minus the square. The square is 2 squared. And I'm going to add the 4 triangles. 4 times half times base times height. The base of the triangle is 2. And the height is 3. So that's good that we don't need to work it out, okay, because we're already given that the height of the triangle, that's the height, is 3. Alright, so here's our triangle. Okay, if we weren't given that, and we were given the perpendicular height of the solid instead, then we need to use Pythagoras' theorem. We need to use Pythagoras' theorem to work this out. Alright, good thing we don't need to do that, so let's just put this in our calculator. Now this is exact, so we've got 3 times √2 squared. √2 squared is just 2. So 3 times 2 is 6, so we've got 6 pi. And then we can just pretty much do the rest in our calculator because there's no pi in there. So we've got 2 squared, actually let's do this, minus 2 squared plus 4 times half times 2 times 3, which is 8. It's positive 8 plus 8. Surface area, so this is centimeters squared, because all of these are in centimeters. What about volume? Volume is just half of a sphere, 4 on 3 pi r cubed, plus the volume of a pyramid is 1/3 area of the base, which in this case is a square, so s squared, times the height. But remember, this is the height of the solid. So this one here, this is the height. We will need to use Pythagoras' theorem to work it out. Alright, so half times 4 on 3 pi times r cubed. The radius is √2. Plus 1/3 times s squared, which is 2 squared, times the height. the height is, because this bit here, because this is 2, this has to be 1. This is 1. So the height has to equal to 3 squared, the square root of 3 squared minus 1 squared. Alright, so let's see what we get with this. Half of 4/3 is 2/3. Okay, so if you put that in your calculator, you get 2/3. And we're multiplying by root 2 cubed. Now root 2 cubed is root 2 times root 2 times root 2. And root 2 times root 2 is 2. So 2 times root 2 is 2 root 2. So this bit here is technically 2 root 2. So let's just do some working out. We know we've got 2/3 pi times 2 root 2 plus this bit here is 4/3 times, well, the square root of 9 minus 1, the square root of 8. The square root of 8 is actually 2 root 2 as well, if you think about it. Because root 8 is equal to root 4 times root 2. Okay, 4 times 2 is 8. And the square root of 4 is 2, so that's 2 root 2. So I might just rewrite this as 2 root 2. Alright, so let's see if we can tidy this up a bit. We've got 4 root 2 pi on 3. Plus 8 root 2 on 3. Now we can make this one big fraction because they both have the same denominator, so we might as well do that. 4 root 2 pi plus 8 root 2 all over 3, and that will be in centimeters cubed. And that's the exact volume of that solid, or that composite solid. Alright, I hope you're having fun with this. Let's have a look at question 5. Find the surface area and volume of the composite below corrected 2 decimal places. So whenever it's, corrected 2 decimal places or 1 decimal place, that makes it nice and easy. Just chuck it in your calculator. Don't need to worry about exact values. It's just exact values that makes it a little bit more tricky. So let's have a look at this surface area. We only have the curved part of the hemisphere and the curved part of the cone. So technically that's 2 pi r squared for the hemisphere and pi rl for the cone. So let's start substituting values in. The radius we know is 1. The slant height, oh, that's this bit here. We don't have that yet. So we need to work it out using Pythagoras' theorem. Since this is the hypotenuse, we need to add. So this is going to be the square root of 3 squared plus 1 squared, which is going to be the square root of 10. But we can just put this in a calculator. No need to worry about exact values. 2 pi times 1 squared plus pi times 1 times the square root of 3 squared plus 1 squared. 16.22. Okay, 16.22. Let's write that again. Meters squared. Right, volume. Well, we got half of a sphere, pi r cubed, and we've got a cone, 1/3 pi r squared h. So let's sub in the values. The radius is 1. The height of the cone, right? This is the cone. So we're talking about the height of the cone, which is 3. Right, let's put in our calculator. I know half of 4/3 is 2/3, so I'm just going to put that straight into my calculator. Times pi times 1 cubed plus 1/3 times pi times 1 squared times 3, which is 5.24 meters cubed. Okay, last one for this lesson. Find the exact surface area and volume of the composite solid below. So this time we want exact. Alright, so pause the video, have a go. Alright, let's have a look. Surface area. We've got the curved bit of a hemisphere, so that's 2 pi r squared. And we've got the curved bit of a cone, pi rl. So let's sub in some values. The radius here, we can see here that the radius is 6 because this bit here is 6 meters. 6 plus 13 gives us the 19. If that's 6, this is 6 as well. Okay, so that's the radius. So radius is 6 plus pi times 6 times the slant height. Now we're not given a slant height, this one. We're not given this. So it looks like we need to work it out using Pythagoras. Again, that's a hypotenuse. So we need to add. So the square root of 6 squared plus 13 squared. Alright, now because we want exact, I'm not going to type pi in my calculator. I'm just going to type 2 times 6 squared, which will be 72. So that's 72 pi. And I'm not going to type pi in my calculator for this section either. But let's see if we get a nice answer. 6 squared plus 13 squared. No, we do not get a nice answer. So let's see what just 6 squared plus 13 squared is. 205. So we get 6 root 205. 6 root 205 pi. Alright, and so that is it. So I'm going to put this in brackets. This is surface area, so this is meters squared. What about volume? Volume, we've got half a sphere. And a cone. 1/3 pi r squared h. So let's sub in some values. Okay, I did half of 4/3, which is 2/3. R is 6. And the height of the cone is 13. So, again, this bit here, because it's separated by a plus, this belongs together with that pi. So I'm going to type the 2/3. I'm going to multiply it by 6 cubed to give me 144, so that's nice. 144 pi plus what is 1/3 times 6 squared times 13, because we don't type the pi in. 156. Okay, so that's 144 pi plus 156 pi. And technically these are like terms. It's like saying 144x plus 156x. Well, what's 144 plus 156? 300. So it's like saying it's equal to 300x. But instead of x, I'm saying pi. 300 pi meters cubed. Alright, so that's it for this video. I hope you found this video helpful. So let's just recap what we looked at. Okay, so in this lesson we looked at how to solve problems involving composite solids, where a composite solid is a solid that consists of two or more solids. So surface area, you have to be careful. Remember, we're only considering the outside, what we can actually touch, not what's on the inside. So think about what formulas to use. Think about which parts of the formula is relevant, because not all of it might be relevant. And for volume, think about what fraction, pretty much, am I using? Do I use the whole formula? Do I need to multiply the formula by some sort of fraction? And things like that. So if you found this video helpful, please give it a like. If you would like more content like this, then please subscribe. If you have any questions, just comment down below and I'll get to your question as soon as I can. Have a good one, and I'll see you in the next video. Bye.